This episode of Serverless Chats is sponsored by Epsagon. This week, I chat with Ajay Nair about revolutionary serverless at reInvent. This is Serverless Chats, episode number 80. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today I'm speaking with Ajay Nair. Hey Ajay, thanks for joining me.
Hey, Jeremy. Finally on the show. Yay.
Well, I am glad you're here. So you are the Director of Product for AWS Lambda at Amazon Web Services. So I'd love it if you could tell the listeners a little bit about your background, kind of how you ended up at AWS, and then what does the Director of Product for AWS Lambda do?
Well, first, thanks for having me on the show. I've been a great follower of both your talks and blogs for a long time, so I'm excited to kind of finish what's been an interesting year by spending time with you. I've been at AWS now coming up in about 7 years, been with the Lambda team for pretty much the whole time. Tim Wagner and I were the founding folks for AWS Lambda way back when. I spent a whole bunch of time at Microsoft and some other software companies before that in a combination of development and program/product management roles. I ended up at AWS really just looking for an opportunity to go and build a new product or a new service in the cloud space. I'd done a whole bunch of things with developer and big data platforms before, and they signed me on this top secret effort, which they said was going to be a new way of doing compute. And here we are 7 years later with me as the director of product on this space. So my role as director of product really is to help figure out the why and the what of what we should be building and evolving Lambda for. So everything that's happened to Lambda over the last 7 years is in some way my fault. But in all seriousness, I get to spend time with customers, figure out what the right thing to go and build for them is, and help the team build it, and then help the marketing and sales team sell it. That's kind of what my day job is, and it's been a great ride for the last 7 years, and here I am.
That's awesome. Well, I'm super excited to have you here. You said it was an interesting year. That's probably an understatement. But not only an interesting year in terms of everything that's been happening, but also an interesting year for serverless as well. And we just finished, I think it was week 27 of reInvent. Oh no, it was just week 3, but it felt, I mean, everything this year has just felt like it dragged on incredibly long. But so there were a lot of really cool things that happened with serverless this year. And your purview is more around Lambda, obviously. You're the product, the director of product there. But there's so many services and things that happen at AWS that interact with it. And I think what would be really great to do, and I want to be respectful of your time and of our listeners' time, because I'm sure you and I could talk for the next 10 hours about this stuff and then have to take a break and talk for another 10 hours. But so we'll time box this a little bit. But I do want to start with just kind of a year in review of the things that have happened with serverless, with Lambda. What are some of the new capabilities? What use cases do those open up? And so let's start with reInvent. Let's start with the big ones that happened at reInvent. And we can work our way backwards, and then hopefully we can kind of put all this stuff together. So let's start there. Let's start with the big one. At least I think this is a huge one because it opens up a lot of, I think, capabilities for other people to get involved. And that has to do with container packaging support. So what's the deal with that?
Yeah, so the idea behind this, as you said, is allowing you to bring Lambda functions, packages, container images, and run them on Lambda. This is an evolution of the theme we have seen for a while where there's a set of people who say, I like to build my code a certain way, but I want to run it the Lambda way, and zip just isn't my style. And actually, more specifically, I think the interesting aspect there is Lambda has enforced this sort of dynamic packaging structure, right? Like where the runtime and layers are bound at execution time versus doing something statically. And I think something's just happened since the beginning of Lambda is this evolution of more consistency across local and online development and trying to push that forward. And we just saw a great opportunity of saying, the container ecosystem's done a really nice job on the tooling and developer front of this. Driving consistency across the two brings the best of both worlds over there. And we've tried to do some interesting bits over there too, like with the runtime interface client, allows you to kind of work with Lambda's event-driven execution model while using the container development model. The runtime interface emulator lets you get much more consistency on your sort of local testing than we have had in the past. I mean, we've had great community heroes like Michael Hart essentially powering large pieces of that. We have taken some of the burden off his back by standardizing some of those components and taking it over there. But it just, to your point, opens up a whole set of new use cases, right? Like if you've previously committed to the container ecosystem as a tooling enabler for you, right, you now have access to all the goodness that Lambda was bringing for you as well.
Right. And that's one of the things that I thought was sort of interesting. When I first heard about containers on Lambda, I was like, oh no, what's happening here? And I love containers. I know I sort of joke about it. I'm not a fan of Kubernetes, but that's for different reasons. But the idea of containers running on Lambda, I was thinking, that seems like that now we're really confusing things. But it's not really like a container running on it. It's just really the packaging format, right?
Yep. Yeah, it is. It's just the packaging format. The team and I joke that if people thought serverless was a vague term, wait till they hear about containers. You start realizing the word container is used as a packaging format, as an execution model, as a slang for Kubernetes, as a sub for an architectural pattern like microservices. And when you go and tell people, hey, Lambda now supports containers, they're like, wait, all of the above now work on Lambda. And so you kind of have to do a little bit of separation, saying, no, it's the packaging format. The execution model stays the same. It's still that, ephemeral model, event-driven behavior that you get. You get still all the security and isolation behavior you're used to. You can just package code in a much more familiar way and get access to a broader ecosystem of tools.
Right, and especially with the idea of the images being able to be 10 gigabytes. I mean, now you have this ability to put all of those libraries in there, package those all together, not necessarily have to worry about the Lambda layers and connecting all those things.
Yeah, exactly. The size is one. That's one we actually debated quite a bit. Like I'm a big fan of less is more. I'm not a big fan of writing fat lambdas and all the other variants that are out there. But I think the 10 gig one is really interesting, especially for some of the emerging use cases like machine learning and larger images and dependencies coming in. So yeah, I'm just excited to see what people do with this larger limit and kind of play around with it too.
Right. Now, I know Andy Jassy had announced EKS Anywhere and ECS Anywhere, but really what you kind of get with Lambda now, too, with this packaging format is you kind of get Lambda Anywhere, right? You can sort of run this Lambda execution model in different places. Not that you would want to, but if for some reason you did, that's certainly an opportunity.
Yeah, I would say you can run Lambda functions anywhere. That's a key distinction. I think, one thing I just want to make sure is this is not about recreating Lambda the entire service elsewhere, which is what ECS and EKS really let you do. They let you replicate the service in your own environment. But from a perspective of taking the same code and running it in multiple places, kind of what that container ethos really embraces, very much possible with the runtime emulator and otherwise. There's still a bunch of work for you to do. Lambda does a bunch of work for you underneath the covers, right. But at least it's possible right now, much more than it was before.
Awesome. All right. So then the other big one for me had to do with reducing it down to 1 millisecond billing. And I've talked to a lot of people about this. They said, well, my Lambda bill is only $100 a month anyways, right? So it's really not that big of a deal. We'll get into a couple of reasons why it is a big deal connecting some other services. But 1 millisecond billing, what's the thought behind that?
Lambda has to get faster, better, cheaper. That's kind of what my driving philosophy was always from the beginning. It's funny, 1 millisecond billing was one of the things that Tim and I discussed the immediately after Lambda GA. And we were like, well, we're not quite there yet. We just got the service started. Let's figure out what the response is to the product before we go and push there. But realistically, what we saw was, you're kind of seeing this breadth of use cases on Lambda where a whole bunch of people are like, look, it's a couple of seconds, larger workloads, big data, Kinesis, et cetera, for these data intensive processes, but a lot more interactive workloads, especially when there's a bigger push for performance, lighter weight runtimes like Go and others are running in that sub 100 millisecond bucket. And we're like, look, there's a way for us to save them, 40, 50, 70% of their bill by just changing the billing granularity at no effort for themselves. Like that's a huge value point. And if you can go and tell a customer saying that, hey, you actually making your performance better is going to make that difference, right? You're actually literally saving money by making the experience better for your customers. That was a really compelling value proposition for us. Like we just felt like there was an entire class of use cases we could make 70% cheaper. We found a way to make the money work, and we're like, yep, let's ship it.
Right. No, that's awesome. And I actually saw a tweet. Somebody showed a graph of what their Lambda bill was before and after 1 millisecond, and it was like a 40 or 50% reduction. I mean, it was huge. And I think there are some of those use cases where if you run enough of them and enough frequency, that really matters. And optimizing to get under 100 milliseconds, and not meeting it and running for 101 milliseconds and getting billed for 200 milliseconds. Yep. I mean, there's a huge cost savings there. So another big thing, just in terms of optimizing speed, and this is something great that Alex Casalboni has done with his with the power tuner, right? Now it's 10 gigabytes of memory with up to six virtual cores. So now you have an opportunity to really tune that even more and get those things just cranking. And of course, the use cases that opens up.
Yeah, exactly. I think one of the internal demos we had done was running a 30 millisecond ML inference, which used about 4.5 cores, which spun up to about 15,000 concurrent at peak. And the bill was sub $50 at that particular point because it ran for such a short duration of time. And I think for us, these two features are sort of enabling different points in the spectrum, right? Like 10 gigs and 6 cores enables you to far more data intensive use cases, compute intensive use cases for running sort of these bigger, beefier workloads, not feeling capped or restricted by the amount of compute available to you. And 1 millisecond was saying, well, you can still do that in this sort of really microcosm of usage to get that cost efficiency, even when you're running these really, really large scale workloads. And to your point, Jeremy, I think that combination is really powerful because you can now performance tune to a point where you get to sub 100 milliseconds and you're incentivized to do so, right? You're incentivized to keep pushing that number even lower with the new 1 millisecond billing.
Yeah, no, that's amazing. All right, so then a couple of other things that launched at reInvent had to do with sort of just event sources and controlling event sources. And this is a really long conversation, so we're going to have to try to keep it somewhat short. But the big news, I think, was, again, Apache Kafka and Amazon MQ opening up as additional event sources for Lambda, which is important, I think, because you do have a lot of enterprise workloads or existing workloads that run on those types of services. So it's a nice little gateway into serverless to start introducing some more of these serverless things. You can comment on that if you want to. Less interesting to me because I moved away from those because I use all serverless things now. But what I thought was really interesting were two things that launched. One was custom checkpoints for Kinesis batches and for DynamoDB streams, right? So you have, if people are unfamiliar with this, and you should probably be explaining this, but you had the ability to bisect batches in the past, where you could say if the first half of the batch, you keep splitting the batch so you could get rid of that poison pill, but you would reprocess the same event or the same message over and over and over and over again until it was finally in a batch that fully succeeded. So that's changed now with custom checkpoints. Can you explain that a little bit better than I just did?
Well, I'm going to try. That was a pretty good one. But that's the philosophy behind it, is that this is a more advanced failure management scenario when you're processing complex batches, right? So Kinesis Dynamo is the oldest event source for Lambda at this point, right? So you're going to see more of the enhancements coming out on that front. And what this now enables you to do is get far more granular control when you're processing these larger batches, right? So one core use case we've seen for Kinesis and Dynamo is these sort of analytical and aggregation patterns, be it for IoT signals or you're bringing in like machine operational data in there and doing so. Right. And we kept seeing this pattern of people saying, well, it's not just a collection of records that's bad that showed up over a window of time. There's this one record that has malformed patterns or records, and this just enables them to say that, oh, now I failed, let's stop right here, checkpoint, and move on. That was one thing they really liked with what they do with sort of KCL and if they're self-hosting, but that felt like an artificial choice, right. I have to either use KCL or self-hosting, we'll go over there.
Yeah, no, and again, that just, it opens up it just opens up a huge level of efficiency. And the other thing is, maybe people don't think about it this way, and I don't know why I'm always thinking about the billing aspect of it, but that reduces billing because that is less invocations of your Lambda functions in order to process those events, right? Because if you're processing the same batch over and over and over again, you're reprocessing the same thing multiple times. So again, just another way to kind of bring that down. The other one, though, is the idea of tumbling windows in Lambda. And this is super exciting for me because I actually, one of the PMs reached out to me many months ago, and I gave some early feedback on the design on this, and one, I think that's a huge testament to, and I'm sure I was just one of hundreds of people who probably commented on this, but it's a huge testament to what AWS does in really getting these things in front of their customers early, and trying to figure out what those use cases might be, before they end up. So you're not just, sort of building things in a void. But tell us a little bit about tumbling windows.
Yeah, no, it's funny. This is actually a really good example of that, because when we originally started out this feature, we just thought of it as stateful processing for Kinesis. And over time, we were like, look, it doesn't make sense for us to just go and say, here's state, good luck. You have to kind of make it work for a specific aspect that works in this particular scenario. And again, tying back to that analytical use case, right? We kept seeing this repeated pattern of people running code on their Lambda functions, writing some little bit into DynamoDB, reading one record from DynamoDB, and then processing and moving forward over and over again. And we said, look, we can just simplify this entire stack if you just enable Lambda to have a little bit of smarts in how it passes data back into the reprocessing of the Kinesis or DynamoDB stream. And that's kind of where we took this tumbling window operation. That's a pretty standard one in most stream analytical behaviors out there, and said we now support that operator. The actual primitive enables is much more fascinating for me. Tumbling window is just one specific pattern that this enables, right? Like you could look forward and say, hey, can you do other kind of aggregations on this? Like, can you now have a formal, this is a primitive reduce. Can you do something even more smarter over there? Can you now combine it with something like step functions and start building even more smarts on how these all orchestrations come together? And I think that's what is really cool about this in terms of how it's actually built out over there. It is one of the top. It's been less than a week since it's come out, but the internal data shows it's quite popular already.
I can imagine. Yeah, no, it is. It's a huge solution because every other solution you'd build around that was something janky, right? It was like loops and step functions, or like you said, writing data into DynamoDB and then reading it back just to do some simple, just to pass in the aggregation or whatever it is. And the aggregation, the state itself, I think can hold up to a megabyte of data.
Yep.
So, it can hold a pretty good chunk of data that gets passed from invocation to invocation. And so just super interesting there. You mentioned step functions. And again, I know step functions are a little bit outside of your purview, but super important as an interface into AWS Lambda because they enable you to do orchestration. And this is going to go back to why I think the 1 millisecond billing is so important, because what we used to see with Lambda functions with step functions is you would use that oftentimes to do function composition, right? You might have a function that does some sort of conversion of your data, another function that maybe writes that data somewhere, another function that then maybe processes it some other way or generates an event, and then maybe something that returns it, and back to another system. And that was always one of those things where it's like you're paying for every transition, you're paying a minimum of 100 milliseconds for every single step function that runs. And by the way, it's asynchronous. So really, it's got to be a background job that runs anyways. Synchronous express workflows, I think, are one of the coolest things I've seen come out of AWS in a very, very long time. Maybe even cooler than Lambda, because what this allows you to do is this is the answer to function composition, at least in my mind. So no more fat lambdas, no more lambda lifts, no more having to push a bunch of things behind the scenes. This is now a way that you can say, I have a Lambda function that does this very specific thing, generically, by the way, right? It doesn't have to have a whole bunch of specific things that it does, or it doesn't have to be tied to resources. Then I have another Lambda function that does this, another Lambda function that does this. I want to put those all together, and I want that to happen in a synchronous loop. That's possible now.
Yeah, no, it has been 6 years since Lambda came out, so it's about time something more cooler than Lambda launched for sure. This was actually one of the really exciting launches for me too. So as you can imagine, in my role, I end up working quite closely with a lot of the broader serverless portfolio at AWS anyways. And, the step functions in Lambda is sort of PB and J for us at this particular point. So this particular pattern, it's funny you bring this up. One of the things we were really excited about was this exact granularity of resourcing and duration that will enable because of these synchronous patterns, right? So we had customers who were doing metadata retrieval, analytical and processing using an ML model, and then a long IO wait time to write the output into something all in one Lambda function. But then they had to run it as, it was like, I think a 1.8 or a 2 gig function because they were like, hey, we have to run this major processing on it.
Right.
Now that whole thing splits up where you have like the cheapest Lambda with actually now you can do sub 128 mil. So you can have a 64 meg function just doing simple IO, finishing in a couple of hundred milliseconds. Your ML model beefing up to 10 gigs and doing the whole thing, and then a simple IO write again at the end doing super cheap. Your overall cost will reduce by at least probably 20 to 30% in that, but your performance behavior looks kind of consistent, right? I mean, this is one of the things we were really excited even when we put Express out there is it enables you to run a whole bunch of things at scale. Async was sort of the first pattern that it went out with, and now with sync use cases, you have, like you said, all these new things that are opening up. So that was one of my favorite non-Lambda launches inside reInvent as well.
But it ties so closely to Lambda, and the reason, and you mentioned this is the pattern. It's that 64 megabyte or the 128 megabyte of RAM in order to do something simple. And I wrote a blog post a while back that was basically about if you're paying to wait for Lambda, especially if you're paying to wait for something like an API call, then don't run it at a gig of memory. I mean, that doesn't make any sense, right? Run it at 128 because it's not going to be any faster or slower. And if it's any slower, we're talking milliseconds. But this is what I love about single purpose Lambda functions in the first place is the isolation model, not just from the idea of, just that code is very simple and it's running it there, but you have the security isolation, you have the concurrency isolation, you have, the memory isolation, you have all that stuff that's there. And if you think about the ability to say, I can run this particular Lambda function to maybe, hit an API, and all it's got to do is bring that data back. And I can run that, like you said, 64 megabytes, then pass that response into something that can do the actual processing on it or whatever. So that's super huge. I love that pattern. And what's another thing that was launched at AWS at reInvent that was announced was now that you can invoke these synchronous express workflows directly from HTTP APIs. So now you don't need a Lambda function sitting there saying, okay, I'm going to invoke this, wait for the response, and then spit it back. Now you just take that step out, you go directly into the step function. And again, any things you want to add, of course, security and authentication, that's all added at the API level. But anything you want to do within that, you get all that data, you get everything you need to do these really complex synchronous workflows. By the way, in parallel too, if you want to run parallel execute, there's all kinds of crazy things you can do, all within this single round trip to the server. I'm gushing about this, but to me, this is just fascinating.
Yeah, Jeremy. I mean, the stacking was conscious, right? So HTTP APIs on synchronous APIs on Lambda functions was exactly the pattern you're going for. I think this is one I'm really excited to see how the CDK folks will respond to this because it lends itself really nice to sort of these programmatic creation of more complex things using these service primitives in the end, right? Like the API and the workflow and the functions express this code, kind of bringing it together. One interesting thing even about the isolation model is one pattern we started seeing already is customers splitting up their execution role for all these individual functions. So the first function that's retrieving metadata only talks to the DynamoDB table. The second function only talks to S3, and the third one only talks to the HTTP API. Like that granularity of isolation and even interface isolation, so to speak, and what they speak to is extremely powerful. Not to mention the fact that the teams can work on those things separately if they so choose. Yeah. So this is one that hopefully next year you and I are having an entire dedicated session just about this, with my step function plans, of course.
And the reuse. I mean, that's the other thing to me that I think is really interesting is the reuse aspect of it. So you're right. You can have one function that can only talk to DynamoDB, while another function only has the secrets available to communicate with the Twilio API. I mean, there's just so much isolation and the principle of least privilege there. But then the ability to reuse it. I mean, build a generic function that queries Twitter, and all you do is pass in what the hashtag is that you want or something like that. So there's just a lot of really cool stuff we can do that. Okay, I want to move on because we've got more to talk about. Before reInvent, there were a number of really cool things that came out as well. One of the big ones was EFS integration. I know this happened quite a while back, but this was something I think big, not for a lot of my workloads, not a lot of use cases that I have, but certainly the naysayers on serverless ML. You can't do machine learning in serverless. This was a big one, I think, to kind of quiet them down a little bit.
Yeah, I mean, I will say one thing that is always fascinating to me is how much social media chatter happens about Lambda for web backends and API use cases, whereas how much of our internal usage shows up for these really brutal data intensive use cases, right? Like one of our big public customers who talks about it all this time is like Fannie Mae running Monte Carlo simulations on Lambda, right? And like this whole ML inference is a huge segment that has kind of grown for us even more. And you saw this in the 10 GB launch as well. I think for me, EFS is a combination of things. One is, like you said, just knocking off the I can only use 512 megs limit inside Lambda. You're actually getting a solid persistent store that comes with it that is as performant, if not, matching Lambda's behavior in terms of ephemerality and billing and others that go with it, but sort of just enabling sort of these really fast access patterns on Lambda that meets the performance need that customers have. Like I think Azurian has a story out there about how they're using Lambda for these ML model storages at this point using EFS for exactly that reason. Like they're able to serve customer-facing requests on that particular stack running really, really fast. And that combination of 10 gigs, EFS, et cetera, is kind of pushing you towards this new use case direction of ML inference that I suspect we'll be hearing a lot more of in the future.
Right. Yeah, no, and again, it's to me, it's a lot about use cases. I mean, even one of the other ones that launched sort of pre-invent, I think it was maybe in October or maybe November, was SQS Batch windows. Simple thing. I mean, but again, when you added SQS as a trigger to Lambda functions, I think it was in 2018, that opened up a whole bunch of really cool things where now you didn't have to have cron tabs running to poll it and whatever. But then I think what people quickly realized was now, if you've got small batches or things coming in too quickly, or not quickly enough, I should say, you've got this issue where, you're executing a lot of Lambda functions over and over and over again, potentially, needlessly. Whereas now you can put them in batches of 10,000 and process some big batch. Now, again, no bisecting there, no iterators and things like that on an SQS yet. I'm sure, but that, I mean, that's one of those things. That's one of those things I thought that was a really interesting one. And then Lambda Extensions. So that was another one that got that was fairly recent. So this is something where, and maybe this is a pattern that we're starting to see, but the extensibility of Lambda, right? Like making it, and again, it's called extensions, but this idea of extending Lambda so that you have more control over the runtime, you have more control into the execution model, into the lifecycle hooks and things like that. So what's the thinking? Well, maybe explain what Lambda extensions are, and then sort of what the thinking behind that is.
Yeah, no, that's a good one for us to get into. So the idea behind Lambda Extensions is built off something we launched called the Extensions API. So it's a peer to the Runtimes API that we launched in late 2018 that allows you to access essentially lifecycle events from the Lambda execution context. So when the execution context is spinning up, when it's being shut down, when something is running inside it, so when your function's actually being invoked. We also launched something called the Logging API that gets you, programmatic access to the logging streams that are being generated from within that execution environment and the code that's running into it. Now, what this conceptually enables, this was very much one for our partner ecosystem, right? So one thing we realized very quickly is customers like using their own tools, right? Like it's good if there are defaults, but they like their own tools. And we've had this whole great ecosystem even around Lambda with people like Epsilon and Tundra and IOPipe and New Relic and Datadog and others who are trying to make sort of the Lambda debugging and diagnostic experience really powerful. But the fact that they didn't have access to this additional metadata was kind of kneecapping them. So we said, okay, let's open that up. You will notice one of the things we really tried hard to do with extensions is it doesn't change the experience of the person writing the function, right? The person writing the function still just either includes a layer or does something different. It's these partner ecosystem people who are building the extension who get these additional capabilities. They're like, oh, now I can know when a function is started. So I can start tracking a specific trace at that point. I know when the execution environment is spinning down, so I can flush my log buffer and send it out there. Or I can expire my credential because the function has gotten, it's finished. And so I need to write something back to vault or checkpoint. Like it just enables a whole bunch of these patterns around how the function itself is operated that I think is really, really powerful. And it's another one of those buts that you're clearing out for Lambda, right? Where you're like, I would love to use Lambda, but I can't use my own operational tools. Well, now you can with identical capabilities really to any other compute system that you have out there.
Yeah, and I want to get into the partner aspect of stuff, but I want to finish up with sort of these launches, and then we can sort of jump back to that. So a couple of other things, and I'll just mention these quickly. Event Bridge, archive, and replay events. Again, not necessarily something that you're working on directly, but I feel like most of the tail end of events end up hitting a Lambda function in some way. And then X-ray integration with S3, just this ability now, if you're using S3 with your Lambda functions, being able to trace that all the way through is super important. There were a number of really cool launches with Amplify and some AppSync things, just giving you different ways to do stuff. And these patterns, and we talked about this a little bit earlier, whether they're DLQs for Lambda functions or, event Lambda destinations, or it's tumbling windows, or it's, iterator control, or it's more control over how Lambda consumes these events from other things. What is they seem, I don't want to say they seem inconsistent. That's not the right way to say it, but some services offer X and some services don't. Is that a general goal? Is that something that we might see where we see some more consistency across the consumption?
No, so I will say inconsistency is not the goal, but neither is consistency, right? So I think the way I think for me, event-driven architectures is something serverless has brought to the forefront. The idea of composing services together with strong contracts and APIs events is the lifeblood of what people like you and me spend our days obsessing about. So making that pattern more resilient and performant is something you're going to keep seeing. What you're seeing with these controls is having them show up where they're most affinitized, right? So with event and replay, what we kept seeing was sort of this idea of backlogging and replaying state events, especially services that are coming to EventBridge, made the most sense there. So that's kind of where it showed up first. With Tumbling Window, analytics was the big use case that we saw that control work the most for. And that's why you're kind of seeing it show up with Kinesis first. My rough prediction, and please don't hold me as a roadmap goal on this, is what I would say is you'll eventually see that sparse matrix getting more filled up, right? Sometimes more as a bet that says, hey, this is something we think will be useful for this customer base because we're seeing sort of this cross pattern. But in other cases, just because, like you said, the demand will start showing up. And I think DLQ is a great example of this. Like SQS started with it way back when, Lambda launched it, EventBridge now has it. And I would predict each of these integrations is going to see that pattern get more and more. So yes, you will see this get consistent over time, driven both by customer demand and where we see opportunities to make life simpler for these event-driven patterns built using AWS services.
Yeah. Well, this past year, I did a talk that I gave a number of times called How to Fail with Serverless, that basically was analyzing all the different ways, all the different failure scenarios and how AWS is built to handle them. A lot of different things, synchronous versus asynchronous versus stream-based versus push, a lot of different ways that these things get handled. So seeing these patterns, be broader so that you can use them on different services, I think is going to be a great thing. So awesome stuff there. Okay, I want to mention two other things and then ask you a question about something that wasn't launched. So Aurora Serverless V2, again, outside of the Lambda team, but I just think generally a really good a much better way to do MySQL or Postgres, at a serverless scale. So just a really good on-ramp for serverless. I mean, it just kind of it lessens the pain of somebody moving into Lambda functions and realizing, oh, I need to set up RDS proxy and I'm going to have all these issues with things. Just the scale, the reliability of the databases when you overwhelm them. So what are your thoughts on serverless V2? I mean, obviously it's a good thing, but just overall impressions on those types of services being built that are really, I guess, complementing the scalability of Lambda.
Yeah, no, I think you're going to see this pattern of service-driven primitives, right? So databases as a service in the true sense of saying pure usage-based, highly scalable and burstable like Lambda is, really cost efficient on a per granular basis, evolve more and more. The Aurora team's done a really nice job with serverless V2. I've had a chance to play with the early versions of it as well and kind of how it plays with Lambda. I do anticipate that we'll drive some consistency between that and RDS proxy over time so that you kind of have this continuum of saying your own database, connectivity, serverless, serverless database or a RDBMS with Aurora Serverless V2. And then who knows, right? Move on to DynamoDB if that's kind of where your flavor stands. But it's more about enabling that continuum for me and kind of making sure that you have good checkpoints along the way of going for it. So if you're a customer who cares about the RDMS pattern, but is willing to kind of go AWS native on using some of these core capabilities with the cost efficiencies and performance you can get, it's a great choice that works really well with the way most people are running applications right now in this behavior. It's not just Lambda, right? Like even if you're using containers or EC2, it's the same behavior that you will see.
Yeah, and I'd love to see V2 sort of handle the RDS proxy thing for you, so that you didn't have to do that yourself. And again, Data API was a step in that direction. Anyways, very cool. Okay, I want to shift to my favorite sort of runtime environment, which is Node, right? So they announced the other day AWS SDK for JavaScript version 3. Very, very cool because it allows you to import just individual service packages as opposed to the whole thing. Probably not overly exciting for you Python and Go developers and things like that, but exciting for us Node developers. But the question that I got was, why no Node 14 runtime for Lambda?
Yet. Look, I think we have had a pretty good record of keeping up with Node releases. We have not done as well as in keeping the window close to 90 days as I would have hoped to. But it's a question of when, if not if.
All right, I'm sure that'll make people happy. And again, you can always run your own custom runtime if you really need it. Hi everyone. I want to take a minute to thank our sponsor, Epsagon. Epsagon enables teams to instantly simplify, visualize, and understand what's happening with their complex microservice architectures. With their comprehensive, lightweight auto-instrumentation, users are able to eliminate the gaps in data and manual work associated with other APM solutions, providing significant reductions in issue detection, troubleshooting, and resolution times. Epsagon aggregates, unifies, analyzes, and correlates data from all the third-party tools you love, delivering a single pane of glass for understanding serverless, containers, Kubernetes, and more. Engineers now know when something is wrong and can immediately trace issues to root cause before they affect production. Increase developer efficiency and reduce application downtime with Epsagon. And as a special for Serverless Chats listeners, if you try out Epsagon and connect your first trace today, they'll hook you up with one of their awesome t-shirts. Check it out at epsagon.com/serverlesschats. So let's move on to a talk that you gave at reInvent this year, and it was called, Revolutionary Serverless or something. What was the name of your talk?
It was building revolutionary applications the serverless way.
Right.
So there were a couple of versions of the title in there when they kind of changed the launches coming in, but that's the final one that ended up. Yeah.
So I watched this talk and I was highly anticipating this talk because, again, you being, involved with all the different teams that are building these features for AWS, and then obviously, connected with all the other teams that are building these ancillary services and other things. I was really looking forward to this talk, and I wasn't disappointed. I thought that you did a good job of all of the things you can't say, because I know that's a tough thing with AWS. It's like, I wish you could say, oh, we're building this, but you can't say that, and that's fine. But I think what the talk did for me, at least, was it reaffirmed the commitment I think that AWS has made to serverless. And I know I was disappointed last year that there were very few mentions of serverless. Even though there were things that were launched and there were a lot of sessions, I felt like serverless was very much so front and center this year. And I think your talk and also Dave Richardson's talk and things like that just kind of went over what has been launched and why you're launching it, what the tenets behind those things are. So I'd love to get into this a little bit, and I'm going to put the link to your talk in the show notes. I think you probably have to be registered for reInvent to watch it. It'll probably eventually be on YouTube, but it should be on demand at this point. But I do want to start with the idea of these tenets. And part of it is, and I guess there's maybe 3 or 4 of them in here, but let's start with this idea of serving builders. What's that about?
Yeah, no. For me, the reason I included that in the talk was to reaffirm the idea that the serverless motion is ultimately about delivering value to your customers, right? The ultimate customer for us is someone who's building software to deliver end customer value. The goal is not to make infrastructure cheaper. The goal is not to just drive utilization to Amazon servers. The goal is not to offload workloads of data centers. It's to help builders move faster. And that's a tenet that's repeated often within the team, just to kind of reaffirm saying your ultimate customer is the developer. They have an entire ecosystem of people helping them out. You have operators and others to kind of go and do that. But there's a developer problem you're solving. The developer's job is to, deliver value. The challenges they'll face are doing that at scale, at cost efficiency, and others. The things they fret about are things like security, performance, and scale. And that's kind of what needs to be our world in how we go and build over that. And hopefully you'll see this reflected in the whole thing, right? You'll see our services are designed as application primitives. We talk about applications front and center all the time. We talk about application patterns that are enabled. Everyone who's out there talks about how quickly they're able to build and deliver value. And I think that's what resonates for us when we say, okay, this thing has actually got legs. This whole motion is about doing less to do more, as I think you've said quite often too.
Yeah, no, and I think the idea of being more productive, building things that aren't, this term has been used a million times, but undifferentiated heavy lifting, right? This idea of doing the same things, and just enabling people to build better things. I remember, I think it was last reInvent, we were having breakfast together actually, and you asked, how do we explain serverless to people or something like that, and I said serverless is just the way. At least for me it is. And then it's funny because now this is the way is from The Mandalorian. I don't know if you watch that show. Anyways, I think he's talking about serverless though. But there's some design philosophies that have to sort of go into understanding how it is that you provide people with the tools that they need. And so you've got some design philosophies that are this idea of ephemeral, which I love, right? Like this idea of I've had so many companies that I've worked for that have had a server up and running for this server's been running for 6 years. Don't reboot it, because if you reboot it, we have no idea what will happen. And that's the worst thing you can do. Also, this mixing requests, right? So you have things that handle multiple concurrency. I know it sounds good that you can handle a lot of requests with a single server, but that introduces a lot of problems, right? And then you also have this issue where, again, back to the idea of not being able to shut that server down, where if you have to babysit something, because if something changes or the memory gets wiped or something happens, and this goes back to that sort of cattle, not pets argument. So talk a little bit about that design philosophy.
Yeah, no. So I spoke about this in the context of what I call compute for all, right? So one of the big things that Lambda was enabling was saying it's the ultimate democratization of compute. Like, how can I give you access to the entirety of AWS's compute power without you having to become an expert in distributed computing, right? Like dealing with all the scale problems and others that go over there. And the reason we kind of picked these 3 as sort of our driving tenets was exactly what you called out, right? If you look at core problems that customers deal with around, security and maintenance and otherwise, part of it is driven by the fact that they assume this thing is alive for a long time. The longer it stays, the more craft it enables, the more complicated it becomes to spread the workload around, right? Like you get into say things like affinity and state, which gets far more complicated. The entity becomes addressable, not just for your attachment purposes, but for security purposes, right? And security is like a really top tenant. It is the top tenant for us as we're building through, and it's one that we want to pass on to customers on that particular front as well. And for me, people often say, "Oh, you're saying ephemeral. Ephemeral means not durable." For me, it's more the temporal ephemerality of it. Like it exists, but it only exists for a short period of time when you need it to exist. And I'm not saying that means, oh, there's a finite, as long as there's a finite bound to existence, that's what matters. And that's sort of human conceivable. So if I start saying, oh, it's finite bound, but it's bound for a month, you're kind of breaking the model a little bit over there, right? But like 15 minutes, 30 minutes, an hour, like sure, that's right. Within bounds, like that you're still within bounds of things being cycled and cleared out and going out over there. And like you said, the same thing with tenancy and isolation, right? Like one request, one execution environment was driven by the same thing. You need consistency of performance. That's a hard problem to do in distributed systems. You need isolated resources to run and execute the code that you're doing. That's a hard problem to go solve. You can enable multi-tenancy, but again, like you said, it sounds great in practice. And there are a whole bunch of patterns you have learned in the past that do it really for efficiency reasons, right? Like the funny thing I keep, whenever I talk to people about multiple requests per execution, they're like, well, it's because it's cheaper. I'm like, great. So what if I made it cost you, 1 cent per billion? Is it okay then? Or they're like, yeah, oh yeah, then I don't want to write multi-threaded code. I'm like, great. So let me do that then. I'll make it cheaper for you rather than forcing you to write multi-threaded code on that particular front. And it's that combination for it. And for me, the last bit that Lambda does really uniquely even now is saying you deal with resources. You get CPU, you get memory, you get compute, and your code is the thing that's important. That's the addressable thing, not the resources. You're not binding your function to a collection of machines or a pod or anything that's addressable. You're just saying, I want this much memory every time it runs. And whether I spin up 18,000 cores in the back end or 1.8 cores, that's not your problem. That shouldn't be something you worry about, where those cores exist, where all that happens. That's going to be the driving philosophy over there. And again, the whole idea is the less things you have to think about from a distributed computing perspective, more than what you need to build and deliver value to your customers.
Right. Yeah, and so the other thing, the other piece of this is that you provide all these primitives, and capabilities, and I love this idea of democratizing, compute, because that's one of those things where I remember long ago, just having to order racks and racks of servers from Dell and paying thousands of dollars a month in order to put them into a co-location facility somewhere. And even just EC2 instances and VMs. I mean, that was a huge step forward where I remember I was paying, I don't know, something like $5,000 or $6,000 a month just to run a co-location facility. I moved it all into EC2 instances and it dropped to $700 a month, right? I mean, just that huge shift there. But now we're not even talking about $700 a month. We're talking about, maybe $1 a month if you're building a startup. I mean, you can get so cheap to do this that now the barrier to entry is incredibly low. But there's a caveat. There's always a but to these things. And that has to do with, one of the philosophies you mentioned was personal productivity. And I find this to be one of the most frustrating and the consistently the thing I hear from other people I talk to all the time is the frustration over developing serverless applications. There's SAM, there's serverless framework, there's Claudia JS, there's Begin, the architect framework. There's all these different ways that try to make it easier for you to build serverless applications. But one of the complaints that I've had, and I know other people have had this complaint, is that AWS isn't always the best with tooling, right? I mean, the tooling is somewhat disconnected. It's not always consistent. But that's something where, I mean, and again, I'm not even sure there's a question in here, but just more along the idea of saying, I get that that's a tenet, and what are the plans? What are you planning on doing? I mean, to bring that, to make people more productive. I mean, obviously, I think the container aspect is one thing, right? Meeting people where they are, giving them more capabilities. But what are the other things maybe that you're trying to do or have done that you think are sort of solving that problem?
As you can imagine, Jeremy, like this is one of the top things that keeps me up at night as well, right? Like, how do you make? On one hand, we're saying we're about making builders more productive. On the other hand, the feedback we hear is you're not doing enough. Like, you have to kind of
Right.
keep pushing the bar over there. And there's a lot of things AWS does well. I think we're really good at building services and growing them. But when it comes to aspects like developer experience, and this is where the personal productivity aspect comes to me, I think the nice thing about the philosophy, at least my team follows, and I know AWS overall does, is we can't do this alone, right? Like it's not easy to go in and just say, this is the way you're going to do it, take it or leave it, and then get out of the way, right? And that's fine. That'll work for all, that'll always work for a niche audience. But if you want to go broad with your story, it has to be something that you do in combination with others. So I think for me, a big push that's kind of where the big push between the runtime API, container support, and even extensions comes in, right? Like, how do you get the rich ecosystem of partners around AWS to help customers solve that problem and kind of do better on that particular front? So I think that's one. I think I'll go back even to serverless framework. Like, serverless frameworks was actually put out by Austin and Co first, even before Sam and others came out, right? Like, and that was one big enabler for the early drive around it. And that was a really nice innovation out there. It kind of started tackling the problem of standardizing and deploying serverless application that inspired a whole bunch of other tooling pieces that came around as well. So that's one. I do think serverless has a unique challenge where you kind of have, there's a new conceptual learning that you have to go through. Applications are built composed of services talking to each other through APIs and events, where there really is no defined pattern. So you're now starting to create tribes, right? So you have a bunch of people who are like, no, this should look and behave exactly like web frameworks, and I'm trying to build end-to-end stuff. And you have kind of the Claudias and others show up over there. There are others who are like, no, I'm just going to treat this as a general purpose, slightly better infrastructure as code story. And that's where you kind of have the SAMs and the CDKs with their own tabs versus spaces debate that is kind of sparked off over there, right? And I would say the real big opportunity, and I actually really like what the Begin and Architect folks are doing over here, is starting to sort of embrace that serviceful nature of it and go, how do you make it easy to compose services together and build forward and do more over there? And I would say that's what you will see, the place you will see AWS potentially invent, and I do this pretty across our services, is when you start seeing commoditization of these particular patterns, right? So that's kind of what happened with SAM. We saw every single tooling provider going in saying, I need a way to express a serverless application as a combination of services. We're like, okay, all of you don't solve it 10 different ways. We'll do it. We'll give you a default standard CLI, but by no means are we saying only use the SAM CLI. It's an easy and default way, and we're going to keep trying to make it better. But there's always a rich ecosystem of tools that you're going to go and do over there. Same thing with diagnostics. With extensions, you've gone past CloudWatch. You now can use Datadog and New Relic as much as you do over there. So I know I gave a non-answer to your non-question, but the whole idea is that I think we're not going to be able to do this alone. This is going to be an ecosystem story over there. AWS has to get better on offering more vertical solutions in these particular things. And I think that's kind of where the space you will see us investing more. I love what the Amplify team is doing. That's my favorite example of a good, simple experience that they're able to do with good defaults, end-to-end experience, focusing on a single use case.
Right. Yeah. And that is always where, and again, my criticism is only because I want it to get better. And I think that, the constructive criticism is always good. But AWS is always very good at building these stacks of these stacks of services, like these services that do a very, very good or simple thing. And I guess that's, you mentioned in your talk, this idea of application primitives as a service, which I think is a really good, sort of way to think of it, where you've got your compute and data, you've got your integrations, you've got your tools, security and admin all baked in. I think those are great things. But you mentioned something that is probably is the hardest thing to explain to people sometimes. And you said, about Architect sort of doing a good job of connecting services. Cross-service connectivity is extremely hard. It is not an easy thing to, one, do, but also to grok. I mean, just to understand how service X connects to service Y, and then of course the observability challenge that's in there. But so just a little bit more on that. Like, I know there have been things that launched at reInvent in this past year, but what is AWS doing to make that easier?
Oh man, I think this is actually something AWS just needs to solve on our own, right? This is not a tooling or ecosystem problem. We own the services, we own the interfaces between them. We have to make it easy. So as with all things, security comes first. So you will see sort of this consistent pattern of resource-based policies between each one, IAM-based roles policies between each one, granular tenants being talked to about each one across the spectrum of services that can talk to each other. I think for me, the next big one is around sort of these reliability controls, right? So the DLQs, the checkpointing, and others that enable to kind of go and do over there, because a message, you need to know who you're talking to. You need to be able to talk to them securely. You need to be able to get the message to them quickly and in a reliable fashion, and you're sure that gets one to the other. And I think then it opens up this pattern of saying, now what are the new sort of line specific use cases that you can enable, right? So this is where your batching, your replays, your aggregations, time windows, and all of those show up. But because you own both sides of the equation, that's kind of where the power of AWS can really come in. Like, we're really good at doing reliability, performance, security, scale. Like, we should make that as much as possible easy for you to do. I think my prediction for you is, I would say, you're going to start seeing a far more consistent API-driven story for enabling all these controls across all these connections. You're going to see less and less of this required to be solved at a tooling level, and more of this being solved at the API level within the AWS services. And even in for the broader set of services to participate in this, I think that's where EventBridge comes in, right? Like, EventBridge has to encapsulate all these connectivity as a service capabilities.
Right.
And so that if you have your own SaaS service and you're like, well, in order to talk to an AWS service, I need these, security, availability, reliability controls, you just plug into EventBridge and that gives you all of that in a box. But for all the other connectivity, it should just be part of the API, right? Like, my dream is the event source mapping that we have for Lambda just sort of universally works for any pattern that you see out there. X-ray just flows end to end within the service. Tracing is enabled by default. Logging is enabled by default. But you need a North Star to keep going towards it. And as with all things AWS, it comes together quickly and over time.
Right. Yeah. Well, and I think you mentioned too the API economy in your talk, and I think this is fascinating. And I know one of the developer advocates, I think for the Amplify team, had written an article about sort of a big difference between sort of the haves and the haves not in the API economy a little bit. And that's probably a longer discussion. But there are a lot of APIs. People are building serviceful applications now. That's just the way that it's going, right? So you have this idea of saying, look, if I want authentication, I can get that from Cognito, but I can also get it from Auth0. And if I want email as a service, I can use SES, I can use SendGrid. If I want SNS, I want SMS, I can use Twilio, or I can use SNS. So there's all these different services that are there. But what I think is really interesting in terms of what can be done, and you mentioned this, is that interconnectivity between those services where, everything is in silos right now. So you say SNS is a service, and I have to understand the nuances of interacting with that particular service, like it is with any API. And that, I think, is a huge opportunity for AWS to say, if you just need a queue, you just attach, Lambda to it, and it just handles all those things that you would want it to handle. And you're not writing all that code, right? Just reducing the amount of code that you're writing. And again, I don't know if there's a question in there, but I think that's really interesting, especially considering the fact that serverless, to me, is more serviceful now, right? That's really a good way to think of it. It's just, what are the, maybe just for the benefit of the users or people who are not quite convinced yet, why is this sort of serviceful movement such an important thing?
It just flat out, I think that is the biggest vector to speed that serverless brings to the table, right? Like, the fact that you can cherry pick components of your customer or product by relying on other people's expertise, right? So going out there and saying, hey, I know, Jeremy Daly, you have built this great chat service that has, and I trust you to offer me 4 nines availability and a certain performance guarantee. And as long as I use your API, I'm good. The incentive for me to go and rebuild that elsewhere is negligible. Like, it doesn't help my business to go and rely on anything else. And I think what that basically does is you are now recruiting an entire collection of experts, of really deep domain experts, to be part of your operational team, to be part of your development team, right? They're continuously improving their portion of that tiny little product. And making it better to move faster. The scale is getting better, the performance is getting better, the capabilities are getting better, while you innovate on the part of the stack that you want to. And what's fascinating for me is, that is the true vision that we had all had when we went down microservices development as well, right? You can do independent development of different pieces. They're all, small pieces loosely joined that talk to each other, and they can innovate separately. The only difference is this is not just your organization sitting and doing it, your 2-person startup. You have now, 22-person startups and AWS innovating on your behalf just to make your product better, right? Like your 1 millisecond example is a great one. Like if you were a startup who was running on us today, and you happen to use Lambda for your backend compute, your bill just got 40% cheaper, which you can now pass on as end user savings with you doing nothing. Like imagine how much work you would have to do to go and that kind of get that behavior over there. And just one more thing, Jeremy, since you brought that up, I do believe the true power is going to be connecting all these SaaS services together and getting them to interconnect a lot more. You're starting to see this with some of the bigger ones, right? So Twilio, Workday, Atlassian, they've all added this programmable SaaS component to them, right? They've got these Lambda-based extensions that they're showing up, like Twilio functions and Netlify functions and others, that allows them to add just a little bit of logic to them to then talk to other services via API calls, and kind of build forward over there. So I think just the flexibility and power this enables is really, really cool. And the fact that you can swap out one API for another is quite a testament to the whole dance around, am I really locked into a particular provider or not? Because it's quite easy to change an API call more than anything else.
Right. No, absolutely. And the speed of that is, just the speed and the less maintenance and all that kind of stuff. I actually saw a tweet the other day that said something like 99% or your library only handles 99% of my use case. So I built my own, right? Like it's the same thing with APIs. It could apply there too. So don't, if it does 80%, just use that, you know what I mean, and work around it another way. But building your own service is crazy. All right, we're running out of time here, but I do want to just go over at least a couple more things quickly. One of the big things is that at the end of your presentation, you had this slide that was, why going serverless is revolutionary. And it was because it's 30x faster development, 60% lower TCO, and just the availability, security, scale, all built in, trillions of invocations per month. The biggest thing for me here is the TCO, because I think people miss that the total cost of ownership of having to maintain these other things. Like, yes, maybe a particular Lambda function costs you $30, $40, $50 a month, and maybe thousands of dollars a month, depending on what your use case is. But you might say, well, it's 20% cheaper if I just run an EC2 instance, or maybe spin it up on containers or something like that. But there's a lot of operational work you're missing there.
Yeah, I think this is the hardest construct for people to understand, but also the most powerful one for serverless to internalize. To your point, infrastructure costs are different to compare. I would argue what we have actually seen is in most cases, unless you're running a really highly utilized EC2 instance or a container instance, Lambda would look cheaper for you, as would most of the other managed services that are out there. But there are cases where you can say, hey, I can run this cheaper if I really squeeze it out of my own infrastructure that I want to. But at that point, you are the one squeezing that money out. You are the one pushing the efficiency out of it. You are the one managing that infrastructure. And this is just my personal note. Builders are really bad at putting a dollar amount to their own time, yes. Right? They forget how valuable their time is. And even if you just value your time at $100 an hour or $50. That quickly adds up. Like this is one of my favorite discussion points of people saying, well, I can run this on a 3-person instance. And I'm like, great, that's good. How many people do you spend on this? It's like, oh, it's right. One on call for a month. I'm like, great. How much are you paying per on call? And then they're like, well, I don't know, what, $5,000, $10,000 a month? I'm like, okay. So now how did that compare to that Lambda bill that you just changed? And you kind of see the GIF with graphs and figures floating around their head to go through. We have to do a lot more to help customers internalize that. And you're going to see more, I think, material and content come out from the AWS team on helping customers understand both their individual costs as well as sort of how you think about the overall TCO. There's a great paper by IDC out there. It'll be a good link to include in your show notes as well that people can read to get a really good model on how to think about the overall TCO too. But yeah, that's the big one. Yeah, 60% cheaper or a 5-year window is big savings, whether you're a small company or a big one.
Absolutely. All right. So again, we've been talking for a while. I do want to move on to a couple of other things. One thing that was really exciting to me was during Andy Jassy's keynote, he mentioned that 50% of all new services being built on AWS use Lambda, which is just an insane number if you think about that, which is great from a serverless adoption standpoint. So that's great. And I wonder why this is. I wonder, again, is it just because it's becoming more popular? Is Lambda just now one of those things that is becoming a little bit more mainstream? And I'd love to think that, yes, just it's gaining in popularity, but I think part of that has to do with this, we can't use Lambda because X, right? And all those objections that we've seen just getting crossed off the list. And the talk that I want to bring up is Adrian Cockcroft had an architecture's trend and topics for 2021. And he spent the first part of it talking about serverless. And in the talk, he basically said serverless is the fastest way to build a modern application. I agree with this. You agree with this. We know this, right? Not everybody agrees with this. And most of those objections have been around things like portability, scalability. The cold starts has always been a good one. State handling, run duration, complex configurations. And there's been all these objections. And back over the summer, there was a conference that he gave a talk at where he basically just picked these things off one by one. And he updated that through this talk. And he mentioned a few things like portability, new container support, scalability, now 10 gigs of space, complex configurations, AWS Proton, which we don't have time to talk about that, but maybe some other time.
Part two.
But
right.
just your thoughts on this growth of serverless. Like, if you go all the way back to the beginning, it was a new thing. So what's happened over the course of the last 6-7 years that have just that has made this thing such a juggernaut?
Wow. I will say when we originally wrote the talk for Lambda, when we launched it, I remember Tim and I sitting up the hour after it was announced, watching the previous sign-up counter go up, right? We were like, will people grok this? Will the idea that you can have a managed compute service that does things for you, this whole concept of events and others, really grok over there, just work? And it did. Luckily, here we are, hundreds of thousands of users, trillions of invocations, so to speak. I think for me, Jeremy, the big thing, what we're seeing is we found a nerve on helping people move faster. The core problem we are solving of saying we have democratized access to big distributed compute in order to build these complex applications at a rate that you can't do before. That's always been the underlying philosophy behind it, right? You don't have to know how to build a service, just give us code and you're basically getting code as a service that goes over there. I think the journey over the last 6-7 years has been enabling new patterns, as you called out, right? And I would actually tie back to the same talk things, right? One has been expanding the capabilities the compute can do for you, things like EFS, things like Firecracker, where we enabled a better isolation model, expanding the amount of compute available for you for 10 gigs and otherwise. The second dimension has been sort of expanding new patterns, a big push being, again, event-driven computing, connecting services to each other, serviceful architectures. I think we are at 140 plus event sources at this particular point in terms of the capabilities that you can use with Lambda, where we started out with 3, right? It was Kinesis S3 and DynamoDB. That's been a huge growth vector for us. And now bringing that to even services that are non-AWS. So, you called out MQ and self-managed Kafka now that we just announced it, including AWS managed Kafka. That pattern continues to be evolved. And then sort of this third one around enabling more developer tooling and productivity. And I think that last one, honestly, internally, the big flip for us was when we started becoming standardized with the internal AWS tooling, right? That was kind of when we saw the big inflection point. And that was one of our earliest signals where we said, you can have the compute be really powerful and enable a whole bunch of new application classes, and motivated people will jump the graph to do it. But you have to keep smoothing the plank, so to speak, to help customers come on board, which is where sort of this push towards opening up the ecosystem, enabling the tools that customers care about is something that you will keep seeing us do a lot more. I think for me, the biggest fascinating thing about the serverless ecosystem is what Lambda has sparked, right? We never went in defining Lambda is serverless, and serverless is the new way of doing things. So hey, here's an easier way for you to run code. Have a go. That sparked the serverless ecosystem. I think the kind of services that we have seen inspired by the idea that you can keep having, spin down to zero, highly scalable, completely apps built by the millisecond conversations with services out there, which wouldn't have been the case, 6 years ago. We were still talking about billing instances by the hour and discussing the next .xxl 5p thing that came out at that particular time. And that conversation's changed. Like I was really the most ironic moment for me was getting into a debate with a customer in June who was basically really upset at us by the fact that we were doing 100 millisecond billing. He's like, that is not acceptable. Like, that's a really low standard for AWS. I'm like, dude, I'm so happy that you're complaining to me that I'm not billing you enough. I'm billing you for too many milliseconds. Like, that is the dream. that we're getting into that argument versus anything else. So when you look at companies like Steady or stuff like what Joe Emerson and team are doing in over at Branch, like you're now starting to see this new flavor of single-digit people startups that are just going to become, $100, $200 billion companies. And this is very similar to the wave that you saw in the early days of AWS as well, right? I think there's a new micro SaaS ecosystem that's serverless has spun up that's really, really fascinating to me, which then also feeds up into how other people are building applications, right? Like, the services themselves are going to be enabling new application patterns. So I do feel the big thing that's happened is the vision of saying, let builders build, let them do more with less has been realized. Not just because of Lambda. I think the entire ecosystem has evolved around it as people have realized and kind of putting things together. And I think that's what's the biggest excitement about this for me is that now people are building things that they never thought they would. They're launching companies they never thought they would. We've seen this whole wave during COVID where people are building, response sites and distribution systems and others in like weeks that they couldn't have thought of handling. And it's handling like millions of requests as it's coming in. And for me, that's really humbling and powerful, right? Like something that you build is enabling other people to build things really faster and deliver value. And we just hope to see more of that coming out.
Yeah, and I love that you use the term revolution or revolutionary in your talk, because I've heard a lot of people be like, oh, it's an increment, it's an evolution of whatever, and I just don't think it is. I think it is a revolution. I think it is a completely different way to think about building applications, and it's a revolution in that it's the people that can rise up to start building these things, where there's just not that walled garden like you sort of talked about in the past. All right, I want to ask you one more thing, and I think this would be a good way to sort of end this conversation, and that's to go back to the idea of the partners. Because I think AWS has been very, very good about creating partnership opportunities for people. But you also run this sort of interesting, this sort of interesting dichotomy of building the tools to allow people to build things, and then trying to build the tooling to solve the other side of the problem, right? So think about observability. I know observability is a frustrating thing for a lot of people. CloudWatch, had some, CloudWatch is CloudWatch with CloudWatch logs. You added metrics, there was insights, there's other things that have certainly gotten better over time. But really, they don't compare to the Epsigons and the Lumigos and some of those. Like, they just do a better job. And so the question is that, where is the line? Is AWS the product or is it the platform, right? And where do you see that sort of going in the future? Like, what are the I know I'm asking you a lot of questions here, but I guess just for me, I'm curious what you see as the continued opportunities for builders out there to build tools and services for other builders.
I should just say yes and call it done, right? Now, I think it is going to continue to be both, Jeremy. And I think this goes back to AWS's philosophy of building backwards from the customer, right? And I think what you're seeing reflected in the way AWS is evolving is also the sheer breadth of customer feedback and signals that you end up getting, right? And I think at least in my time at AWS, what I've seen is there's a class of people who want AWS native, right? They're like, I need this to be AWS, otherwise I'm not going to get it approved. I'm not going to get it through. I'm not going to use pick your own from the toolbox on the side thing. You have to give me a native solution end to end. And it needs to do the basic that's good enough, right? So there's one school over there. And there's the other one who's saying, no, look, I want to use what I consider best of breed that works for my style, my productivity, and others over there. And like I said in the beginning, right, like there's no way AWS can do this overall. So I think for AWS, you're always going to see the core investments in what we consider sort of the core aspects of the service, right? So security, performance, scale, capabilities on enabling sort of API and service-driven innovation. I always think of this as the space being big enough. It's not like if AWS releases a service, it's one and done. Ultimately, customers are going to use the best service that they care about. And I don't think AWS is the only one who can build that best service. That's all the examples you just called out, right? Like there are great ecosystem stories that are thriving and big over there that continue to go big. I think you see the same thing reflected in the way Lambda is evolving, like we talked about, opening up the core aspect of the service, which is sort of that distributed compute democratization is going to continue to be something we innovate in. We have opened up an API on the areas we think where other people can do stuff. Like we're like, hey, you want to bring your own runtimes and patch it better than we do? Go for it. You think you can manage operation controls better than you do? Here's an API. Go for it. Have fun with it. We're going to continue to offer an end-to-end vertical solution for those who do care about it, right? Like, so you do want sort of the sensible defaults, I think is the strategy that we're going to do over there. One thing I have heard a lot of partners bring up is how do you kind of enable better cross-service, discovery? How do you make sure that it's not like they're able to just pick CloudWatch because they're forced to being picked into CloudWatch, etc. And I think that's something we're going to continue to evolve. I actually like what the EventBridge team has done really nicely over here. So if you just go to the Lambda console and try to select an event source from EventBridge, it shows all the different ones who are out there, like all the different SaaS providers show up at the same footing as any other AWS service. And I think that's a philosophy we'll see evolve more. So I think for me, if I kind of bring back to your original question, I think AWS's core value add is going to be solving what you call undifferentiated heavy lifting, which lends itself to be more of the service tier, so to speak, not necessarily a platform tier. And then enabling these experiences on top of it, some which are going to be AWS native and others which are going to be just really enabled by the broader partner ecosystem over there.
Yeah, no, and you said to me earlier, the goal is not to get everything right; it's just to make everything possible.
Yes,
which I think is quite fascinating.
Yes, exactly.
Well, listen, Jay, this was awesome. I love talking to you. Maybe I'll stop recording and we can talk for another 10 hours and not necessarily bore the listeners with it. But this was great. Thank you so much. And not only, just for being on the show, but for everything that you're doing at AWS. I know you were there right from the beginning with Tim Wagner and the others and just, making this what it is at this point. I think I've said this to others who have been involved early on, like, this has just changed my life, right? It's been a revolution for me and the way I build applications, the way I think about applications. And I think this has changed the world for a lot of people. So revolutionary is the word that I would use. So if people want to find out more about you, find out more about serverless, what AWS is doing there, how do they do that?
So first of all, Jeremy, thanks to you and the community as well. It's the customers who keep us honest in helping evolve the service over here. And I think one of the biggest powerful aspects of serverless has been the community around it, and keep spreading the word, keep telling the builders who are listening to your talk about how we can do better. Like you said, the path to the revolution is serverless, and the fastest way to build a serverless, and we're going to keep making that true. I hang out on Twitter quite often. You can find me at Ajay Nair Thinks on Twitter. You can find me on LinkedIn, and I'm usually pretty responsive over there. But otherwise, you can always go yell at Chris Munns, who's our principal developer advocate, and he has a way to find me too.
Right, and a great resource that was launched not too long ago was serverlessland.com, which is really good. So go check that out. Awesome. All right, Ajay, thanks again.
Yes, thanks, Jeremy.
And that's this week's Serverless Chat. I want to give a huge thank you to Ajay Nair for being my guest this week, and to our sponsor, Epsagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/80. For more serverless chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.